Today, we're stepping inside a gold refinery and tracing the entire path from raw rock in the ground to a finished stamped gold bar. Let's dive in. It all begins at a mine, and the first thing that catches people off guard is what gold ore really looks like. There's no shiny yellow nugget lying around waiting to be scooped up. Gold ore is dull gray or brownstone, nothing special to look at, easy to mistake for ordinary construction rubble. The gold hidden inside is tiny, spread out in microscopic specks through the rock at concentrations so low that pulling out 1 ounce means processing tons upon tons of material. In some deposits, you're talking about just a few grams of gold per ton of stone. That's a real measure of how scarce it is. Giant drills bore into the earth, blasting breaks the rock into pieces, and heavy equipment scoops up thousands of tons of this unremarkable material onto haul trucks bound for the surface. From there, it's off to the processing plant.
Stage 1 at the plant is crushing, and the sheer scale of it doesn't sink in until you witness it firsthand. Boulders, some as big as a car, get dropped into primary crushers that break them into smaller fragments. Next, they pass through secondary and then tertiary crushers, each round shrinking the pieces further. By the time the crushing line is done, a boulder has become coarse gravel. Still too big, though. The material then heads into grinding mills, massive spinning drums, some over 10 meters across, packed with heavy steel balls. As the drum turns, those balls crash and grind against the rock non-stop, until it's reduced to a fine powder, almost like dark flour. Mixed with water, this powder becomes what's called slurry, and it's at this point that the real extraction work begins. The whole purpose of crushing and grinding is straightforward. Break the rock small enough that every trapped gold particle is exposed and ready for the chemistry ahead. Once the ore has been ground into slurry, it moves into the leaching stage, where chemistry takes over from raw force. The slurry gets pumped into a bank of large tanks, and a weak cyanide solution is mixed in thoroughly. Cyanide bonds extremely strongly with gold at the molecular level, pulling gold particles out of the surrounding rock and dissolving them into the liquid. This technique, cyanide leaching, dates back to the 1880s and remains the dominant gold extraction method worldwide because it works so well even on ore with very low gold content. The tanks keep the slurry constantly stirred for 24 to 48 hours to squeeze out as much gold as possible. By the end of this step, the gold has been drawn out of the rock and now exists dissolved in the liquid, unseen but present. The next hurdle is pulling that gold-laden liquid away from the leftover solid rock. That's done through a step called carbon in pulp, or CIP. Small black pellets of activated carbon get added to the slurry. Gold clings to activated carbon almost instantly due to a strong natural attraction between the two. The gold-laden carbon then gets filtered out of the slurry using fine screens that let the liquid and ground rock pass through while catching the bigger carbon pellets. What remains is carbon carrying the gold, plus leftover waste slurry, called tailings, which gets piped to a containment site. Tailings require careful handling because of leftover cyanide, and today's facilities follow strict environmental rules for managing them. Meanwhile, the gold-bearing carbon heads to the next step. To remove the gold from the carbon, the plant runs a process called elution, or stripping. The carbon goes into a pressurized tank and gets flushed with a hot caustic soda and cyanide mixture heated to roughly 110 to 130 degrees Celsius. This hot wash pulls the gold off the carbon and into a fresh liquid known as the pregnant eluate. The now empty carbon gets reactivated in a kiln and sent back into the leaching circuit for reuse. Almost nothing here goes to waste. The pregnant eluate, carrying the dissolved gold, then flows into electrowinning cells, and this is where the process starts looking more recognizable. Electric current runs through the solution, drawing gold and other metals onto steel wool cathodes inside the cell, where they build up as a solid layer. Once electrowinning finishes, workers pull out the steel wool and smelt it, burn it at high heat, which destroys the wool and leaves behind a rough gold product called sludge, or doré. Doré is a blend of gold, silver, and trace metals, and at this stage it looks nothing like a finished bar. Dull, lumpy, unpolished. But the gold is there, concentrated and ready for the last step. That last step is refining, and this is where things get dramatic. The doré heads to a refinery, either on-site or a dedicated facility, to push its purity as near to 100% as achievable. The standard modern method combines the Miller chlorination process with electrolytic refining. During the Miller process, chlorine gas gets bubbled through the molten doré. The chlorine reacts with silver and other base metals, turning them into chlorides that rise to the top as slag and get skimmed away. This raises purity to about 99.5%. Impressive, but still short of investment-grade quality. To hit that final target of 99.99%, what the trade calls 4 nines fine, the gold goes through electrolytic refining. The still impure gold is cast into anode form and lowered into a gold chloride bath. When current flows through, pure gold releases from the anode and builds up on thin gold starter sheets on the opposite side of the cell with remarkable precision. What accumulates on those sheets is 99.99% pure gold, about as pure as it gets. That refined gold then goes back into a furnace to melt and gets poured carefully into molds. The pour is slow and controlled. Temperature, speed, and angle all matter. Any trapped air or inconsistency during pouring can weaken the bar's structure or mar its finish. After pouring, the bars cool and harden. They emerge from the molds with a rough surface, so they go through finishing work, cleaning, smoothing the edges, and polishing until that unmistakable golden shine appears. Every bar then gets weighed precisely, tested to confirm its purity, and stamped with the refinery's mark, a serial number, its weight, and its purity level. That stamp is the bar's fingerprint, proof of origin and quality that lets it move freely on international markets. Finished bars then go into secure storage before eventually reaching vaults, banks, national reserves, or buyers directly. A standard bar, the type you'd see in a heist movie, weighs 400 troy ounces, around 12.4 kilograms, worth somewhere between $750,000 and well over $1 million, depending on market conditions. Smaller formats, 1 kilogram, 100 grams, even 1 gram, get produced too, for retail investors and jewelers. Every one of them passes through the same journey: crushed from rock, leached with cyanide, captured on carbon, stripped, Electro 1, refined, melted, poured, and stamped. The full path from ore in the ground to a finished bar spans weeks of nonstop processing, huge energy demands, careful chemistry, and a degree of engineering precision most people wouldn't associate with something as old as gold mining. People have been digging gold out of the earth for thousands of years. The techniques have transformed completely. The fascination with the metal never has. So the next time you spot a gold bar, a gold ring, or even a gold price ticker scrolling across the news, you'll know exactly what it took to get there. If this gave you a new appreciation for what goes into something most people take for granted, hit like and pass it along to someone who'd enjoy it. Subscribe for more deep dives into the factories and processes behind everyday things. See you in the next one.